Okay, we had a problem. Put our values for A through G in order from lowest to highest, in case you didn't have it that way. And then we have a table for a graph of f of x with the values of A, C, D, and G in the x column, corresponding to values F, D, B, and A in the y column. And we're asked to graph this, make a table and graph for the inverse function. And most people did quite well here. And then estimate these values, okay? Now, estimates weren't always done completely correctly, so we do want to make sure we understand how that's done. Well, this is easily enough done using my values. Here's the table. Using your values, the table will be slightly different. But in every case, if A, B, C, D, E, F, and G are in order, these values will be increasing, these values will be decreasing. Now, to do the inverse function, we simply switch the numbers in the columns. So that our x values here are the y values from this graph, from this table. So there they are, these values go here, and the x values go into the y column over here. And now we do the two graphs. Now, I'm not sure I did the first graph, I did the second. Actually, I did the first, okay. And I didn't do it particularly well, but you know, the points on the first were here, and here, and here. And 610 was about here, because then we got 510, 610. We had 412, okay. So these points weren't done all that well, but this white graph would indicate the f of x function. The green graph would be the inverse function with its points. 12, 4, well, 12 is, if this is 10 and this is 15, 12 is about here, so there's 12, 4. 10, 6, there's 10, there's about 6. Again, this isn't done with great accuracy, but you get the idea. 5, 10, there's 5, and up here is 10, and actually that point should have been, yeah, a 610 should have been here on the white graph, and 510 is here, and I kind of slop that in there. Okay, and 4, 15, yeah, 4 is here, 15 is up here. Again, this is not particularly well done. Neither were most of the graphs, although that's no excuse for me not doing it well. There's how we graph it, and we know how to graph these things. So I think everybody did a pretty good job of graphing, but sometimes people got a kind of an anomalous point. Got a coordinate mixed up here and there, and the graphs didn't quite end up looking the way they normally would. But for the purpose of this exercise, if we reversed the columns and did a reasonable job of putting both graphs down, some people did it on two separate sets of coordinate axes, and that's okay also. That was okay. Now, how do we do estimates? Well, we'll get that in a minute. Let me comment first that you know, I did comment on the domains and ranges of these. That wasn't required on the quiz, but it's always a good thing to do to make sure you're oriented to the function. So let's take a lesson here. The domain of the green graph consists of all the x values corresponding to points of the green graph. The green graph starts here at the point 415, ends here at the point 12,4. So there it is. And the x values of these points, well, you just look at the values directly below the green graph on the x-axis, and there they are between 4 and 12. And it's obvious here that 4 is the least, 12 is the greatest. So the domain is 4, 12. The range consists of all the y values. Well, look here. This green segment here is the range of this function because all the y values lie within this green segment, and every value within the green segment corresponds to a y value on the graph. So there we go from 4 up to 15. So the range is 4, 15. Again, this could be drawn much better. Okay, well, what's the domain of f of x? Well, the domain of f of x goes from 4 to 15. You can see right there is where x is 4. Okay, it's supposed to be 4 right here. And here x is 15, and you've got points all the way across. So the domain would be the closed interval 4, 15, and the range would be the closed interval 4, 12, because the x values go from 4 here up to 12 here. Okay, all the x values are in this interval. All the y values are in this interval, I'm sorry. And every value in this interval, every y value in this interval corresponds to an x value on the graph of f of x. We want to see that. Okay, then the domain, the estimates, we're supposed to estimate the value of f. Well, it said f of b, okay? So let's see how we do f of b. In my case, that would be f of 5. Okay, well, according to the graph and not to the table, when x is 5, you go up to the graph of f, which is maybe here and across. And if I do an honest estimate, this was 10 here. A little hard to read, the board's a little rough. F of b would be f of 5 would be here just a little less than 10. So I'm estimating 9.7. Doing an honest estimate of my graph. That's probably not very accurate, but according to the way my graph is drawn, that's probably not too far off. And then f of the e value, well, e is 10, so here's 10. We go up to the f, and of course, the e value is going to be 5. But if I make an honest estimate, the way I drew my graph, which wasn't real precise, it looks like 4.5. Even though I know it's supposed to be 5, my honest estimate is 4.5, which is a little bit off. Then if you want the value of x, well, you want the value of f inverse of c. In my case, that would be f inverse of 6. So what do you do? F inverse of 6, well, here's 6. We come up to the green graph and across, and we get our estimate, f inverse of 6. It's between 5 and 10, closer to 10. It looks like pretty close to 8. I'm going to say about 8.3. So now hopefully you can read that on the video. I didn't write it in because the writing would have been too small to read in class. I said it was around 8. I forget what I exactly estimated. Now if I had a bigger graph, and it's always good to draw a bigger graph, I had limited board space, so I wish I'd have drawn the bigger graph. Should have. With a bigger graph, it's easier to label all this stuff. But the point is, to get f inverse of 6, you find 6 here, you go up to the graph, you come across here, and you estimate the y-coordinate. That should be obvious, because that's what you do always to do a function of a number. If you have the graph, you can estimate it. And then we were supposed to estimate what? F inverse of e, and in my case, excuse me, e was 11. So what would we do? We'd come out to 11, but we find that 11 isn't in the domain of f inverse. Actually it is. It goes up to 12. I'm sorry. I was thinking this was 10. This is 10. Okay. So 11 would be about here. We come up over here and be close to 5. Okay, you have to be able to do these estimates, because it reinforces what all this stuff means. Not only that, but sometimes all you've got is a graph. You don't have a formula, and you have to use the graph to estimate the quantities that you need to use. This happens in the real world all the time.